Okay, now this one's the mother of all parallel circuits, right? All I did was I drew these guys on this side. I could draw them on this side. Okay, there's 4 resistors, right? Okay, so there's a current that goes this way. Let's just do these guys first. And another current that goes this way, back. And then there's one that goes this way, and one that goes this way. Okay, so, and then notice no current goes through the voltmeter because current can't go through voltmeters. So this guy's just measuring the pressure change from there to there. Let's see, let's figure out what these currents are. I'm going to call this guy A, B. I'm going to call this guy C, and I'll call that guy D. Okay? And so A is 13. The formula I'm using is I is V over R, Ohm's law, right? So 35 divided by 13. I'm going to store that in A. That's 2.692. Right? And that's 35 over 13. Okay? B is equal to 35 divided by 17 because it's the current through that guy. I'm going to store that in B. Okay, so B is 2.059. There's a decimal point there, right? And that's, of course, 35 over 17 is what I'm doing there, right? And then C is 35 over 11, right? Okay, 35 divided by 11, storage C. That's 3.18. Ooh, it's 18181818. Just love that. 3.182. Right? Amps. These are all amperes. Right? And that's, of course, 35 over 11. Right? And then D is equal to 35 over 23. So 35 divided by 23 is 1.52, I'll say 1.522. Right, so that's 35 over 23. Okay, so now we're ready to go. A1 is going to be the current A plus the current B, right? IA plus IB. Internal assessment plus IB is despair, no doubt. Okay, so alpha A plus alpha B is 4.75. 751 amps, so that's this answer here. Let's see, A2. My gosh, A2 is like at the nexus of it. Every current that goes out of there, right, is going to go through A2. So A2 is going to be IA plus IB plus IC plus ID. Right, so alpha A plus alpha B plus alpha C plus alpha D. That's 9.455. Okay, let's see. A3 is just going to be these two currents. So that's current C and current D, right? Okay, so that is alpha C plus alpha D. 4.704. Okay, let's see. A4 is just this current. Notice how that one looks like it's going through there, but of course it's out here on this wire. So really it's just that current going through that guy. So A4 is only going to read the 3.182 amps. A4, and that's it. Those are all the ammeters. A1, okay, and then the voltmeter here, right? Well, what's the voltage? Well, a lot of things we can do with this, right? The simplest thing is to just notice that this voltmeter is connected, and we can go from the voltmeter to this side of the battery without encountering any resistance, and we can go from the voltmeter to this side of the battery without encountering any resistance. So that ammeter right there, even though it goes through the ammeters have zero resistance, so they're just like a wire. A good one is, right? Okay, so V1 is simply going to read 35 volts. Right? Now, if you wanted to, this would be silly, right? Is you could do I times R for this resistor, but of course we got the I from the V and the R, so of course I times R will be V. Okay, but you could do that, right? You could say that it's I times R, so it's 1.522 amps times 23. And of course that's going to be, if you don't round this, 35 volts, right? Okay. Yay.